One of the most important gases in the air is oxygen.
Oxygen for medicine. In the operating theatre, oxygen makes it possible for the surgeon to perform life-saving operations. Patients whose bodies are weak from illness are brought back to health in the oxygen tent. Oxygen by the ton is used to make steel. This is a Bessemer converter. Filled with molten iron, pure oxygen is forced through the holes at the bottom. The result, steel to order for modern industry. Oxygen is used by the engineer. Acetylene gas burning in pure oxygen produces a flame hot enough not only to weld, but also to slice through metal precisely, cleanly, and delicately. Nowadays, oxygen is manufactured on an enormous scale from the air, using a process first developed by William Hampson. This is the sort of apparatus he used. Dry air under pressure is allowed to expand very quickly through a long, very fine capillary tube. As the air expands, it gets colder and colder until eventually, at a temperature about 200 degrees below zero, it becomes a liquid. The liquid is then distilled to separate the oxygen from the nitrogen and other gases that are in the air. "200 years ago, no one could have imagined the industrial processes that now depend on oxygen. At that time, men were just beginning to make discoveries in chemistry which would make such developments possible. One of these discoveries took place at Bowood, near Caen in Wiltshire, on August the 1st, 1774. Bowood was the home of Lord Shelburne, who was very active in politics.
It is my view, my lords, that the present quarrel between Britain and her American colonies will lead to serious trouble. Yeah. Will lead to grave consequences.
But, like many noblemen of his day, Lord Shelburne was also a patron of science. He equipped a laboratory in his own house and invited one of the cleverest men of that time to work there, Joseph Priestley. Shelburne gave Priestley a house for his family to live in nearby, and a salary of £250 a year, a lot of money in those days. Priestley was a minister in the Unitarian Church. He combined preaching with a study of science, or natural philosophy, as it was then called. For several months, he had been heating different substances to see if they gave off gases. He obtained heat from the rays of the sun. He used a glass lens to focus the sunlight on the substance he was heating. On this occasion, it happened to be mercuric oxide, which was then called calx of mercury. It soon appeared that a gas was coming from the calx of mercury. Of course, to Priestley, even the word gas was unknown. Gases were thought of as different kinds of air. There was fixed air, which we now call carbon dioxide, and there was inflammable air, which we know as hydrogen, and a few others were known. Priestley must have wondered which air he was collecting this time.
Another experiment, Doctor?
Oh, yes.
Another substance?
Yes?
Let me see now. You tried heating pipe clay, chalk, flint, ground tobacco, muscovy talc, flowers of zinc. What is it this time?
Calx of mercury.
I see you're getting results. Oh, that's encouraging. What do you think this air will be?
To be honest, my lord, I have no idea.
Which test will you try first?
The candle, I think. If the air burns, it's probably inflammable air. If it puts the candle out, it's more likely to be fixed air.
Shall we have a wager, Doctor? The air burns or the candle goes out. Now, which is it to be?
My lord, you know I do not wager.
Merciful heavens.
It's the candle that burns. Did you see it? The candle burns brighter.
It is extraordinary. What does it mean?
I know not any more than you do. I must carry out some more tests.
I warn you, my lords, the fate of the British Empire hangs in the balance. Fate of the Empire. How's the mouse?
Does not dissolve in water, has no effect on lime.
It appears to be in excellent health.
Ah, yes. It's quite remarkable. In ordinary air, the mouse would have been exhausted within 15 minutes. But you see, in this air, it has lived for 30 minutes, and it's still vigorous.
It actually seems to have done the creature good.
Yes. I've a mind to try some myself.
What is your conclusion, Doctor?
A new kind of air. There's no doubt of it. One that encourages burning and breathing better than ordinary air. One might call it a sort of pure air.
Pure air. Most exciting, Doctor, most exciting.
I must find out if there are more substances that
Quite so.
produce
But
it.
do remember, we are leaving for Europe at the end of the month.
Oh, yes, of course. So we are.
Well, you yourself are anxious to visit Paris, I think, to meet the French philosophers.
Oh, most certainly. Antoine Lavoisier, for instance. I'm sure he'll be interested in my new discovery. Do you suppose he'll agree to meet me?
I'm sure he will consider it a great honor.
Shelburne and Priestley reached Paris at the end of September after a tour of northern Europe. Paris was a city of splendid boulevards and fine buildings, together with a stench of poverty which Priestley decided was worse than anything he had known in England. They had scarcely arrived when they were invited to dine at the home of Antoine Lavoisier. There was no stench of poverty here. Lavoisier had inherited a fortune, and he received a large income for arranging the collection of taxes on behalf of the king. Like Priestley, he was already famous for his work in science. His wife Marie, though married for 3 years, was only 17.
Beautiful, madame.
Thank you, Doctor. And now perhaps you will entertain us.
Well, I can play the flute, but...
Oh, tell us more about this new discovery of yours.
Oh, that? I'm sure that's of no interest to a young lady.
You're quite wrong, Doctor. Marie is most interested in chemistry. In fact, she's a valuable assistant to me in my work.
What? Our French lady is so accomplished as well as so charming.
This pure air, did you get it only from calx of mercury?
I have since obtained it from red lead, although the process is slower.
Antoine, could it be the same air that Herr Scheler described?
Scheler.
Yes, he's Swedish, a very clever man. He wrote to me recently describing some experiments that were rather similar to yours.
Then he, too, has discovered the new air.
Yes, it would seem so. But tell me, Doctor, why do you think this new air makes a flame burn more brightly?
Well, it is generally agreed how burning takes place. We must find out how the new discovery fits into the theory.
And what if it does not?
Oh, but it must.
I'm not at all satisfied with our present theories of burning. I wonder if this new pure air might not give us a new understanding.
New understanding?
Antoine is always looking for a theory that explains all the facts, not just some of them.
Bravo. I do declare, with Dr. Priestley's observations and your husband's logic, the world may learn much.
I hope so. And I hope that one day such learning may be put to good use.
May I prevail on you, Doctor, to repeat your experiments here in Paris, that I may see them for myself?
I shall be honored.
Are you satisfied, monsieur?
Magnificent. Did you make a note of it all, my dear? Could this possibly explain? I wonder.
What have you in mind, monsieur?
2 years ago, I carried out some tests. And I came to the conclusion that when burning takes place in ordinary air, part of the air is used up.
Used up.
Used up.
Let me show you what I mean. Now, the candle is burning in ordinary air. Watch what happens when I cut off the air from outside. You see? Part of the air disappears. But since air is a single element, why should only part of it be used up? Why not all of it?
Well, that is explained by the theory. The rest of the air becomes stale.
That is what we assume. But no one can show us what really happens.
I warned you, Doctor. Antoine will not rest till he's found an answer.
A pity we are leaving for England shortly. We shall await your answers with great interest. Eh, Doctor?
Now let's look at the facts. When you burn something in air, part of the air is used up. Yet air is a single element, so why should only part of it?
Yes, dear?
Is it a fact that air is a single element? How do we know it is?
It's always been thought so.
Exactly, it's always been thought so. We let our brains get clogged with habit. But what proof have we got, eh? All right, let us suppose for one moment that air is not a single element. Suppose it contains at least two elements. What then? Is it possible that in burning, one of the two elements is used up completely, while the other, the part that remains, is a different element altogether, one that does not support burning? Do you see, my dear? All might be explained if ordinary air contains two different elements.
But what proof do you have of that?
In due course, Lavoisier was ready to demonstrate his new theory in the laboratory. He took great care, noting the temperature and pressure of the air. The bell jar contained ordinary air. Lavoisier marked the level of the liquid. Then he began to heat a measured amount of mercury. It was a long process. On the second day, small red particles appeared on the surface. This was the substance he knew to be calx of mercury. At the same time, the level of liquid in the jar began to rise, showing that some of the air was being used up. After 12 days, Lavoisier decided that no more calx was being formed, and he marked the level to which the liquid had risen.
Volume of air. That means the air has lost 3 grains in weight.
3 grains. How much has the mercury gained?
Gain in weight, 3 grains.
Splendid, Antoine. So part of the air has been used up to form the calx.
Yes, and this is calx of mercury, the substance which contains Priestley's pure air.
Then there's no doubt of it. The pure air in the calx must have come from the ordinary air in the jar.
Yes, and this pure air is part of ordinary air, which is part of all the air we breathe.
To make his point even clearer, Lavoisier reversed the process. He heated the calx he had obtained, but this time much more fiercely, so that the pure air was driven out again. And, sure enough, the air in the jar was restored to its previous volume. Lavoisier had, so to speak, taken air apart and put it together again.
I am now convinced that air is a mixture of different elements. One of them being the pure air.
But while Priestley and Lavoisier went on with their work, which started a revolution in scientific thinking, other revolutions were taking place in the world around them. On July the 14th, 1789, the mobs of Paris stormed the Bastille. This was the beginning of the French Revolution. Priestley sympathized with the revolutionaries. He wrote to a friend.
I think you will find, John, that the revolution holds out a glorious prospect for mankind.
But most people in Britain were afraid that the revolution might spread. Priestley became very unpopular. He left Lord Shelburne's service and went to live in Birmingham. It was there that his home was attacked by an angry mob. Priestley had to flee with his family. His laboratory was wrecked. Many of his precious books and papers were destroyed. In April 1794, he set sail with his family for America. The former colonies had now become independent of Britain, and Priestley was able to continue his work. Antoine Lavoisier was not so fortunate.
Take good care of these, Marie. One day, when the world is sane again, they'll be of some use to mankind.
Lavoisier, you remember, was one of the men who arranged the collection of taxes for the king. These men were hated.
I have an escort to take me to prison.
No.
I'll find many friends there.
Antoine.
I shall appeal to the tribunal. Men of reason will not condemn me.
These are not men of reason. There is no reason anymore.
And I shall be spared the trouble of old age. I've had a happy life thanks to you, Marie. What more can I ask for?
What's this? More treason against the people.
No.
Burn it, let it burn, I say.
Leave it be. These wise men are all the same. They scribble a load of rubbish. What they write will soon be forgotten, and so will they. Come on.
The record of these vampires is complete. Their crimes clamor for vengeance. It is proved that there has been a conspiracy against the people of France. The following are condemned to death: Clément Delage, Don Bagneux, Antoine Lavoisier.
I then decided upon a name for the new air which Priestley and Scheele had discovered. Since it appears to form acids, I chose the Greek words for acid making, and I call the new air oxygen.